Good afternoon, everybody. Welcome back to lecture number 16. Today we will start talking about induction machines. What is a critical difference between induction machine and synchronous machine in terms of structure? Forget about concept of operation. So for the synchronous machine, we have what? A stator and we have a rotor. صح ولا لا? For the synchronous machine, does it have the same stator as induction machine? Who says yes? Raise your hand. هل الستيتر حق السynchronous machine بالضبط نفس الستيتر حق الاندكشن machine? Yes, raise your hand. No, do not raise your hand. Who said yes? We have 3 yeses. Who says no? Who says I abstain? I'm telling. With those, the 3 guys, what's your names? Ahmed, you should have said. You got it right. Trust yourself. Okay, trust yourself. The stator for the synchronous machine is similar as the stator of the induction machine. It's a metal structure, فيها slots, and there is a three-phase windings. Those windings can be A, B, C, A, B, C, A, B, C, or they can be A, B, 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 C, 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 etc. per pole. Clear? So in terms of the stator, they produce them the same. The only difference is in the rotor. They are not the same. The rotor of the synchronous machine has to have an excitation. Otherwise, what's the point of not having an excitation? If there is no excitation, there is no field voltage. However, for the induction machine, the rotor of the induction machine has nothing, has no energy. Let's talk about squirrel cage. I'm not going to talk about slip rings. Slip rings is an improved version to improve the controllability for induction machine. But for the majority of induction machines, rotor is a dead structure. The synchronous machine, the rotor is not a dead structure. It has a life. It has live voltage in it. And this voltage is DC. Can you replace this DC voltage with permanent magnet? Yes, but still, there is life. Rotor of an induction machine, the squirrel cage is made of aluminum bars. And those aluminum bars, the fact that we have rotating RMF in the stator, this rotating RMF on the rotor induces a voltage of current. يا أخي أشغلتنا بالواجب يعني Did you write your name? مين اللي بس أسامة. You forgot your pen. كتبت اسمك؟ Okay, so that's the thing about it. So for the rotating RMF, what will happen? It will induce voltage on a rotor. And this induced voltage will have a current of frequency FR, which is S times FR. However, the rotor of the synchronous machine, it has DC. We don't care. The other major difference between them is synchronous machine's rotor would run at a speed below the synchronous speed, depending on the loading condition. For the synchronous machine, it has to run at the synchronous speed, no matter what happens. I'm talking about motors, for example. Clear? So, these bullet points, there are 7 major differences to compare the synchronous and induction. The first one, it talks about the speeds. The synchronous machine would run at an average speed that is fixed, while the induction somehow changes its speed. Number 2, synchronous motor. And this is really critical. Synchronous motor, it runs over a wide range of power factors. It can be leading, it can be lagging, it can be unity power factor. But for the majority of induction motors or induction machines, you run them always at a lagging power factor. There is no under-excited induction machine. Okay? So, different speeds, different PFs, and the ability of self-start. So, who wins for the self-start? Induction or the synchronous? Induction, because they can start by themselves. Just connect them to the power supply, three-phase. Three-phase. We had a story about your senior project, and what's the information we learned? Is the only three-phase in KFUPM where? Now, it's here. Downstairs. Okay. So if you want three-phase at KFUPM, the only three-phase we have is here, building 59. You cannot access three-phase. This is useful for senior project. The single-phase induction machine has a certain circuit with capacitors to make the motor self-start. Okay? This is single-phase induction. The changes, here's another thing, the changes in applied voltage do not affect synchronous machine torque as much as they do with the induction. If you increase the voltage of synchronous machine or decrease it, that wouldn't change the torque. However, the torque is highly sensitive with induction machine. It means if you have a certain load, by just increasing the voltage, you can have voltage control over induction machine. But for synchronous machine, that's not the case, and it has to do with the ability of course, self-start, and the fact that synchronous machines, they have to run at synchronous speed. Otherwise, we would lose synchronism. Do not lose synchronism. Do not lose synchronism. The breakdown torque for synchronous machine varies approximately as first power of applied voltage, but the induction, it's with the square. Yani proportional is higher. This has V squared, this has V. DC excitation is required for a synchronous machine. Remember the exciter? You need to have it for both motor and generator. It can be permanent magnet or it can be a certain circuit. We talked about it. Synchronous machines are usually more expensive, more complicated to control because we need power electronics. We have power electronics for the field exciter. Do you remember the field excitation? So if you want to control the field, you need to have complicated power electronics. For the induction machine, you can just change the frequency and the voltage and you get wider range of control. So they are excellent for speed control for high speeds, while for induction machines, while for permanent magnet, they are for lower speed, below 300 RPM. The last difference is synchronous machine can run at very low speed using high power electronic converters, while induction, so those 10 megawatt range are used for driving certain applications like الأفران الكهربائية. Another thing is طواحين المعادن. Induction cannot help. You really need to have synchronous machines to run those big plants. What did I tell you about EVs? We have both induction and we have permanent magnet synchronous machines. In the same vehicle, you can have both. Maybe for front wheel drive, maybe you have induction for the back wheel, maybe you have synchronous. You can have your own design. Okay? And the fact that they have the same stator makes the assembly line more easy. Only when it comes to the rotor, you split the design. Remember, okay? So, you remember in the power electronics, they say the most interesting application is the diode. Or no, it is the transistor, right? They say the most innovative thing is transistor. For other areas, the wheel for mechanical, etc. But I think for power engineers, the most innovative thing is induction. No matter, like you can't deny the fact that thinking about induction is a genius idea. From a genius idea. And it is the black horse of industry. The whole industry relies on induction machines. Induction machines are the default machines for selection. Take it as a rule of thumb. If you want to buy a machine, it's induction, unless otherwise specified. Okay? So induction is the fundamental thing. and it lives longer, it is cheap, doesn't have complicated power electronics. The induction machine, they can operate as generators where? In the wind energy. For wind energy, you have induction generators. Applications, they are in pumps, fans, compressors, paper mills, textile mills, and so forth. And the linear version, they also have linear induction machine. There is linear synchronous machine, and there is linear induction machine. So the stator, I already told you it's the same. You have slots, laminated steel, and put the coils inside and connect them to three-phase. Or if it's induction generator, you get three-phase. For the rotor, you either we have squirrel cage is the most one. You put the cage above the rotor. And you have here, for example, copper bars, for example. Sometimes they make it aluminum, sometimes copper. There is no unified design. So the rotor has laminated material with slots, can be in the outer surface. The rotor windings may be either squirrel cage, or the other type is wound rotor. If it's wound rotor, you need to have slip rings. And why we have wound rotor, we will study it later, is to...
دكتور الفرق بالموتور بين الاندكشن والسينكرونس سكرول كيج excitation بس؟
No. The rotor of the synchronous machine has windings, while the rotor for the squirrel cage does not have windings. It's just bars. There is no slots, it's just bars. It's just bars. While for the synchronous, you need to have windings, you need to have there has to be a current flowing by design. But for the wound rotor, it also has windings. So there is induction with windings. But there is control of slip rings that we connect them with external resistance to control. This gives you better control at starting speeds. Again, for induction, most of them are what? Squirrel cage, unless otherwise specified. So here we have laminated core, here we have coils, here we have slip rings. So this is the wound rotor. So again, you have the rotor, the stator. You can have either Y or delta connection. A, B, and C, each one of them is 120. So A prime with B prime, they are 120 degrees. This is for a two-pole machine. This is a two-pole machine. I'm going through over this somehow quickly because we covered it in 360, okay? The other thing is, look at, for example, time zero here. What is IA? It is I max. What is IB and IC? They are negative IM2. If you convert the current to MMF, note that IA is here. So IB should have a force that is here. Is that correct? So this is IA. Okay? This is I. Okay, this is I. So A is between B and C prime. Is that correct?
Yes.
So A vector is between B with C prime. And it has a value of I max. So if A is I max because IA is I max. And it is in this direction. The IC should be between the B and A prime. But because it's negative, the equivalent one is actually acting in this direction. Get it? Because of the negative sign. So FC, it's actually minus FC is this way. So FC is here. Clear?
Yes.
For FB, the MMF for FB is between the coil A prime and C. The equivalent force, this is a force, this is not a current. This force is because of the minus IM/2, and it is originally in this direction, but because it's negative, it's originally in this direction because it's negative, its impact is here. So where is the resultant one? Add this vector, FA plus FB plus FC, the equivalent is 3 over 2 F max. This is at time t0. At another time, for example, here you will have at t1, IA is 0, IB and IC at value somehow between half and max. Okay? I don't know this value exactly, but it's between half and max. Just below the max. So you get FA to be 0. We don't have it. FA to be 0. So they are not half. FA is 0. FB, this is FB and FC, they also act in separate directions. Flip the arrow, you should also get another 3 over 2 F max. Contribution from only B and C. For another random time T2, you will have IA is minus I max, and the B's, they have to be half and minus half. So the equivalent F max is in this direction. So no matter what you do, the MMF is constant across all the time. That's what we meant by uniform rotating MMF across the time. Get it? So the MMF is because of the current. At every instant of time, get the contribution of MMF of phase A and B and C. If you add all of them, always it is a 3 over 2 F max. That's the best you can get. I'm not going to ask you to analyze them numerically, but I will ask you to understand them. So at a certain time is T0. There is a missing slide, I will add it later, that has the other times. So please watch this YouTube video. This is the same YouTube video in E360 slides. It is very important to understand. The last part of it talks about the control. Focus on the last part. Maybe you're familiar with the first part, but the last part of the video talks about the control. So what happens is you have, since the stator three-phase windings are supplied from a three-phase sinusoidal supply, we get to what we call the rotating RMF. This is the rotating RMF. The rotating field cuts the rotor winding, producing an EMF as the rotor windings are shorted. There is electric current that flows in the coils of the rotor or in the bars of the squirrel cage. What's happening here is the rotating MMF rotates this way. The rotor conductors, either on the bar or wound rotor, they would line up with the south. For example, this is south, they would rotate, but because of a current carrying a coil that is shorted, yani the path of electricity is closed, the coil is shorted from this way to that way, all the bars, they are short-circuited. There be a flux induced due to rotor current, because now we have a current flowing in the bar, there is also another flux. So the flux from the rotor cuts the original RMF that is rotating. We get induction of current here that results in induced voltage, that results in induced another magnetic field. The interaction between them, if you see here, for example, you will note that the arrow here is stronger than the arrow here. This one is in direction of the flux, while this one is the opposite direction of that RMF. You see it? The small cable, I have right-hand rule. Some of the flux is along the RMF, حق الستيتر. The other part of the flux is against, so they will cancel. What's the result? The result that I will have a force that's pushing the cables in this direction, so it will rotate. Clear? Is it clear? Where is Mr. Nawaf? It's absent. Where is Mr. Ibrahim? Where is Mr. Ahmed? He's not here.
Into the bathroom.
Where is Mr. Ali Khalid? Mr. Osama? You have something, wallah, you don't have. I know you have a committee. We're missing you today. Missing your excellent question. Wallah, if you are busy, wallah. عادي والله ما أمر شيء. If you're busy, go focus on your time.
Victor,
Hello.
can you do the right hand rule here? So
Right hand rule only على
yeah, to see the balls.
yeah, only into the page.
Yes.
فالفلكس هذا مع الفلكس حق الار ام اف، الار ام اف من وين جاي؟ من الستيتر.
صحيح.
هنا عكسه. طالما هذول there is imbalance between the resultant flux وفي current carrying cable there is a force. الcurrent carrying cable أو conductor هو الروتر. Stator fixed force will not impact. Clear?
Yes.
So you all know the slip is the difference between synchronous speed and the actual speed over the synchronous speed, which synchronous speed you get it from the same formula, 120 F over S. There is 3 different speeds for induction. I'm gonna explain it briefly. The synchronous speed is the speed of the fluxes. It depends on the supply. If you get 50 Hertz, you're gonna get different than 60 Hertz. If you get 120 Hertz. The rotor speed. What's the speed of the rotor? The speed of the rotor has to do with the relative electrical frequency between the supply and the induced current in the rotor. So if the frequency of the rotor current increases, we're gonna get the induction machine to act slower until we reach 0 difference, and then it will slow down and get 0 slip, and then the current will increase its frequency a little bit or decrease its frequency. So if the rotor current frequency increases, the slip decreases and the rotor speed would be close to the synchronous speed, but the torque would be less, so it will slow down. So the speed of the rotor, it varies based on F2. F1 is fixed usually. F2 changes as a function of the speed. The cutting speed, this is the slip speed, depends on the cutting speed, which is the difference between NS over N. You can normalize it to get the slip, and rotor current frequency. So these are the formulas. F2 is P times NS minus N over 120, which is SF1. Use this formula. S slip times F1. N2, which is the cutting speed, is 120 times F2. In 360, we called it FR. 2 is FR over P, which is SF1, which is S and S. So that's a speed, synchronous speed. Okay? This is a simple example. 3-phase 460 line to line, 100 horsepower, 60 Hz 4-pole induction machine delivers rated output power at slip of 0.05. Find the synchronous speed and the motor speed. Synchronous speed is 120 F over P, 1800. The speed of the motor is 1 minus slip times the speed is 710. This is easy from 360. The part 2 is find the speed of the rotating air gap field. What is the speed of the RMF? The rotating magnetic field, the speed of the vector F that I showed you before. It is the same as the speed of synchronous speed. So it is 1800. Third part, what is the frequency of the rotor? It's S times F, which is 0.05 times 60, 3 Hertz. Keep in mind that if the slip changes, means the speed has already changed, means the frequency will change. And vice versa. So one way to control is if I can, with the slip ring, change the frequency of the rotor bars, I can change the speed the other way. The last question is find speed of the rotor field, which is the rotor magnetic field, relative to the rotor structure. So this is the rotor magnetic field with respect to the rotor structure. Do you think there is a speed?
No.
No. No. What is the rotor field? What is the rotor field? This. It's not only this one, it is the combination of this one and the original one. So to solve this problem, he thought about it, the author of this textbook, is measure it with respect to the rotor structure. He is saying it is 90 RPM, which has to do with the slip. Relative with the stator structure, it's 1800 RPM. Relative with the stator rotating field, RMF, it's 0.
Does it stop moving?
No, they move the same.
Same speed.
They move the same speed. So relative with a rotor field, rotating field, it is the same. But with respect to the stator, it is synchronous speed because the stator is fixed. With respect to the rotor, it is the slip. Remember, he's talking about field, not current. This is field. The rotor field is the summation of whatever goes inside the rotor of fields. It rotates. Find rotor-induced voltage. This is easy. And he's telling you that there is the ratio of turns, the turns ratio between stator and rotor is 1 to 0.5. This is because, remember they told you induction machine, they look like transformers?
Yes.
Only at standstill. So there is, when we draw the circuit, there is parallel component that you need to reflect the voltage. So the voltage levels between the stator and the rotor here is 1 to 0.5. So to find this, it is SE2. What is E2 is 0.5 times the supply. Think of the 0.5 as the transformer ratio, because he's saying find the induced voltage in the stator winding. No, find the rotor induced voltage. Induced voltage on the rotor bars. So there is an air gap, right, between rotor and stator. Think of it as transformer. It is like the ratio of the, yes.
We treat the rotor as the secondary part of the transformer.
Yes, rotor is the secondary part. Then the voltage level for rotor has to do with windings of stator versus winding of the rotor. There, if it's squirrel cage, you have to calculate the equivalent winding. Okay, if it's wound rotor, it has already windings. So the equation is provided here before. It is SE2, but what is E2? E2 in this example is N2 over N1 times N1. Just multiply everything. 0.05 times 0.5 times the supply divided by square root of 3. The equivalent circuit, we all remember the equivalent circuit. So the stator circuit at standstill or zero slip, remove all the rotor parts because the rotor current is 0. It's like open circuit. So the stator and rotor circuits of the three-phase are similar to the transformer with the shorted secondary windings. So this is the equivalent circuit at standstill. V1 is per phase terminal voltage. This is stator, R1. X1 is the rotor reactance, is the stator reactance. RC for core losses resistance. XM is for magnetization. It's for magnetization. We already discussed this in E360. Keep in mind we have magnetization current and we have core current. The other circuit is, we remember we did this thing in E360. I'm not going to go over it. Let's go to the final product. The final product is actually we have stator, we have the parallel components for magnetization, then we have E1 equal to AE2, where A is the ratio between the windings of the rotor and the windings of the stator. And then you connect everything together. We have X2 prime, which is A, you're reflecting the X2 from the rotor side. Remember, it was physically isolated. So now you're connecting everything together. The current is divided by A. This is R2 over S times 1 over S. If you add both of them, you will have R2 prime over S. This is R2 prime plus R2 prime over S minus R2 prime. They will cancel. So this is equivalent of R2 prime over S, which is A square R2 over S. We're reflecting from secondary to primary using the ratio N2 over N1. I'm not going to ask you to analyze the circuits in the test. This is just to refresh our memory, because when we talk about the control aspect of the machine, we know what we're talking about. When we change the resistance, We know the corresponding one from EE360. The losses, if we recall that we have air gap power, we have converted power. What is the difference between air gap power and converted power? So the air gap power is the power that crosses the air gap from the stator. The converted power is the air gap power minus rotor copper losses or rotor aluminum losses. Okay? Depending on the type of conductors that is used. If it's a squirrel cage, then it's aluminum. If it's wound rotor, then it has coil windings on the steel. Now, the difference between the equation is both of them, they would have induced torque. The only difference is here you don't use omega M, you use omega S. Okay? Here you use, so the air gap power is the torque induced times omega S, not omega M, or torque induced times omega S. Why? The friction, it is torque of the friction times omega M, and then the output power is the load at the shaft or the torque. I always bring the example of السطح. الحين في السطح there is a torque. في الونش اللي يسحب, there is a torque on the other side of the car that you're connecting. They have to be greater than or equal. On سطح it has to be greater than, so the air gap torque has to be larger than omega M, torque induced. This is the torque induced, has to be larger than the shaft torque. Shaft torque has to be either equal or below. Otherwise, the motor would not spin. Okay? So torque load is always less than induced for the case of the motor. For the case of the generator, it's the opposite. Okay? So the equations are provided here, and I will... Okay, who's the formula sheet guy? Your name? Ali.
Alwan.
Ali Alwan, you're the formula sheet guy. So please make sure... Do you think you want to have one page? One page is enough?
وجاوبها.
No. It's too much. I major, not fine. So only one page. If you make it small, large, you all agree on it in the group and send it to me, how many hours? 72 hours. And then I will change it. If it's too much, I'll change it. And then I'll post for you the final version. I'll print it for the test. Okay? Any objection about this process? Trust me, this is the best process. This is the best process. Otherwise, if I tell every one of you do your formula sheet 1 hour before the test, you will worry about it. Just make it as a collective of your team. Okay? If he gets A+, you still can get A+ in my class. I don't care. It's irrelevant. But if, for example, Ali wanted to get the B+ and insisted on that, even if everybody got C, he would still get the B+, regardless.
الحمد لله.
ما له دخل. It's about your performance. Please, help yourself, help each other in making the formula sheet. If you get full mark in the major, it will not impact his full mark. ما له دخل. I'm not going to make major 2 harder because an average of major 1 is hard. I don't care. What I care about is knowledge. So please make the formula sheet, 72 hours. Try to put reasonable formulas. You can put circuits, you can put pictures, you can put whatever you want. If I don't think it's suitable, I will erase it. And I will upload the final version. So the equation, if you remember from 360, for example, mechanical power is 1 minus S times air gap. Air gap power is I2 square R2 over S. These are the other two power, has to do with the slip, etc. So this is another example that probably is good to know. So what is 15 horsepower? It is full load, okay? And can you get the slip from this information? Yes, I have the rotor speed, 71728. I subtracted from 1800 because it's a 4-pole 60 hertz. So 1800 minus 1728 divided by over 1800, you should get the slip. And the slip here is 0.04, it's a 4% slip. So I can tell you both information. So the output power, which is basically here, is the rated power. It's 15 horsepower converted to 746, include 746 in the formula sheet. Okay, I'm not gonna give you the number. It's 11,190 watt or 11 kilowatt. So what is the mechanical power developed? You should get the output power plus windage and friction. Windage and friction is 750. It's given. So we're going from here to here, windage and friction. We ignore stray losses. Here in this example, we ignore the stray losses, okay? Then what else you need to do? You need to go and get the converted power, which is so here the question asks about mechanical power developed. We already calculated. What is the air gap power? To get the air gap power, it is 11,940 divided by 1 over S. You can use this formula. Air gap power. Yeah, air gap power is P mechanical over 1 over 1 minus S. Then find the rotor copper losses. To calculate the rotor copper losses, you can use this equation. Where is it? S times PAG. Okay? What is the mechanical power?
Mechanical power made output.
Yes, I think so. Mechanical power developed here rated 15 horsepower plus windage with friction. So this is the mechanical. So mechanical power.
I developed.
هي هذه converted. It is converted from electrical to mechanical. إيش معنى converted? Converted from electrical to mechanical. هذه كلها ME stray والwindage ME not E. So this is converted. And converted to air gap وهذه we call it P2 rotor PRCL هي نفسها P2. You should get familiar with different notations because different textbooks use different notation. And when you go and work for Aramco, some manufacturer will tell you P2, some manufacturer will tell you PRCL. So you have to think. Okay? Then you can use this equation and then you can calculate the rotor copper losses 497, which is nothing. Some engineers would say this is percentage, 2%, 3%, and move. No need to calculate the equation. Keep it fixed regardless of the slip. Look at when you work for Aramco or GE, they always care about large scale calculations. So for example, they care about the efficiency of the machine and then you multiply it with 10,000 machines in your storage. So if you get an improvement of 3%, you multiply that 3% save in energy across all the machines. These are the things that they look for, of expanding a single calculation into large scale, with the ultimate goal of minimizing the cost. Okay? That's very important. The other thing that we talk about is approximated equivalent circuit. I personally do not like approximated equivalent circuit. I don't like them. So I'm not going to explain them. But if you get stuck in the exam, you can remove RC, for example. You can move the parallel branch all the way here. You can do whatever you want. No, you can move it from here to here. So do whatever you want, but I personally, even in E360, what did I tell you in E360? I love this circuit because it is the circuit that is in Simulink. That is why not? Why not we live with one circuit that's somehow complicated? Okay? Now, the other example or the other thing is the torque speed characteristics. So now we're talking about stability. So where do you think we operate our machine? At very low speed or at somehow high speed?
High speed.
Usually we operate across this line from E360. So anything past the peak is a stable region, anything before the peak is unstable. So when you start your machine, you should go to the peak torque. Once you exceed the peak torque, you should go to high speed. So at very low slips, you should operate in the stable region. And to calculate the torque, is keep in mind here we have a 3. We added a 3 to the equation of power to include all the 3 phases. If you have a 5-phase machine, you should put 5.
مو افضل اننا نوبريت اوفر ذا ني؟
No, you operate at close to synchronous speed. Here, depending on the torque that you need. If you need high torque, reduce the speed a little bit. And never go to the peak torque. Your machine should be designed, I think this T peak for operation.
دكتور الرسمة اللي كانت معكوسة في 60.
You can flip it. If you put slip, you can flip it. I provided the two in 360.
Nice.
I flipped the axis. And I also provided this. But this one is more common. Again, you have to think. Every figure and every report, when you work for Aramco, it has to be labeled clearly. If you make mistakes in these things, engineers will never trust you and you'll stay forever in your position. حاجة أنا لاحظتها من زملائي اللي اشتغلوا في الشركات أرامكو سابق etc. is they always brag about الترقية. For example, some engineers took them 6 years to go from grade 11 to 12. While other engineers, it took them 3 years to go from 11 to 12. And another 3 years to go from 12 to 13. That's 2 grades in 6 years versus 1 grade in 6 years. And in 10 years, we can start seeing the gaps. Almost the salary after 10 years of this guy, of this engineer, is double than the one who took the traditional 6. So if you want to take the 6 years, so they will decide the first 3 months when you start work. So the first 3 months, they would say, are you a high potential? The first 3 months, حرفيا. It's not, oh, this year I will have fun, next year I will work hard. No. If they label you as not a hard worker, you better change your company. Okay? It's better. It's better for you to stay until you find another job and change. You won't believe it. Sometimes, يعني واحد دفعة, I don't know, 215 is now a supervisor for واحد دفعة 210. ولا 220 becomes supervisor of دفعة 218, 217. It's very common. It's all about the promotion and how to get promotion better. You really need to, in your reports, you will be writing reports. Who is not happy about writing reports? Do you enjoy writing reports?
No.
Except the team design? So in real life, it's all about writing reports. Yeah, you really need to improve your skills, writing reports. What's the language of communication? So please, in your labels, you have to label. This is the speed, RPM. This is the torque, Newton meter. This is per unit. Learn from the literature. And you have to make your figures clear. If it's not visible, don't put it. If it's not visible, don't put it. Okay? So to calculate the torque, this is the equation. I'm not going to go through the derivation. You can see that if we change either R2 or we change the slip, we can control the torque. We can increase, decrease, etc. So this is the instantaneous torque of the machine. To get the maximum torque of the machine, you really need to take this derivative with respect to the S. So the slip, then you should get the 360 maximum slip and 360 maximum torque. These are two equations. But we, in 462, we bring the game higher. We say, can we divide 1/3, which is the instantaneous torque, over the peak torque? Why we divide them? If I'm at peak torque, if I get ratio of 1, I'm at 100% capability. If I'm at 50%, the ratio will be 50%, or 30%, or 20%. So this way you can know what parameters change your torque with respect to the maximum torque. So if you do this division, and I think, if I'm not mistaken, he added a 2 here to cancel this 2. To cancel this 2. So to make everything as variables without numbers. Because here we have a 3, here we have 3, then we cancel. But here we don't have a 2, but here we have a 2. So I'm not sure, I could be wrong, but he added the 2 to cancel. Time is over. I did not tell you. Okay? So I hope this was a good, quick introduction. Feel free to leave. If you have another class. Next lecture we will have the quiz, and I will bring the swing equation problem. I will just change the numbers. Okay? I'll just change the numbers. Maybe I will change the torque, the power. كم كان في الفولت الباور electrical 0 كان you did not study كم كان 0 PE 0 I might make it 0.3 0.2 instead of a fault. Can you resolve it? Try. Okay? So I just change the numbers. It's very crucial. Okay? No excuse. Quiz 3. And then we'll have next week the mini majors, the fake quiz 4.
Tuesday also.
Tuesday. Okay? Any other question? Stop the recording. شغالة؟